Hello everyone, welcome back to my channel. So in this video, I'm going to explain about AC through pure resistor R from the subject name called Elements of Electrical Engineering, especially for first year engineering students. So now without wasting time, so let us go for the concept. I'll consider a circuit which consists of resistor across voltage source V is given by Vm sine omega t. Here a circuit which consists of a circuit which consists of a pure resistor connected across AC voltage source. So that is given by instantaneous value of voltage, small letter v is given by Vm sine omega t. So giving constant supply voltage to the pure resistor now, so that the voltage which is constant is nothing but I'm considering this as a reference. So now voltage is reference. So now I need to get the value of current that flows through the resistor R. So to find the value of current I, I'm applying Ohm's law. So that according to Ohm's law, you can write I is given by V, that is instantaneous value of voltage divided by R. Whereas we know the value of instantaneous value of voltage V, that is nothing but Vm sine omega t. So that I can rewrite this equation as I equals to Vm sine omega t divided by R. This is equation A. So now I'm comparing this equation A with the standard instantaneous value of current. Comparing with standard instantaneous value of current, that is I is given by Im sine omega t plus phi. So by comparing with this standard equation, so you can easily write maximum value of current Im is nothing but, you can compare this, Im is nothing but Vm divided by R. So Im is given by Vm divided by R, whereas Im is maximum amount of current and Vm is maximum voltage with respect to pure resistor R. Similarly, you can compare the phase angle phi. Here omega t only there, omega t plus, if nothing is there, it means that there is a zero. So that the value of phase angle, that is a angle of current, is 0 degree, whereas the phase angle of voltage is also 0 as it is taken as a reference, and also phase angle of current is also 0 by comparing with the standard instantaneous value of current equation, that is Im sine omega t plus phi. So with refers to this, we can conclude that the voltage and current which has the phase angle of 0 degree, that is nothing but angle between voltage and current is 0 degree, so that you can easily draw the phasor diagram by considering voltage as a reference. By considering voltage as a reference, the current which is in phase with current which is in phase with voltage. In the same case, if you are considering current as a reference, voltage which is in phase with the current. So now the current is in phase with voltage V, in phase with V, so that the angle between voltage and current is 0. So angle between voltage and current is nothing but phi. Phi is 0 degree, which is nothing but power factor cos phi, that is nothing but cos of 0, that is nothing but 1. So that in case of pure resistor, the power factor, nothing but cos phi, which is always 1, so that there will be a unity power factor in case of pure resistor. So that impedance in a pure resistor Z, we can also write it as that is equivalent to R, a real value of resistor. So this is these are the steps that you have to get to know about AC through pure resistor. So here this phasor diagram is very important. By considering voltage as a reference, current is in phase with the voltage. Similarly, you need to draw the waveform. You need to consider this phasor diagram now. The reference is voltage. It is nothing but you are applying a AC voltage, so that the waveform of voltage is nothing but a pure sinusoidal waveform. With respect to omega t, if you're drawing the waveform of voltage and current, so the voltage waveform, it is nothing but a pure sinusoidal waveform like this. Voltage waveform 0 to pi, 2 pi, 3 pi. Whereas you already know the phasor diagram of AC through pure resistor. By taking voltage as a reference, current is in phase with the voltage. It is nothing but a magnitude of current, or else amplitude of current, which is less than the amplitude of voltage. You can observe here amplitude of voltage and amplitude of current, so that the waveform of current is in phase with the voltage waveform, but the amplitude of this current waveform is less than the amplitude of voltage, so that this current waveform, which follows voltage waveform like this. Whereas this red waveform is indicates current is given by Im sine omega t. Similarly, the black line which indicates black waveform which indicates voltage waveform is given by Vm sine omega t. So this is the waveform of voltage and current in case of pure resistor. So the next continuation part is the power in the resistor, pure resistor. So if you wanted to know the power in pure resistor, so let me define first instantaneous value of power, that is small letter p is given by the product of instantaneous value of voltage and current, where instantaneous value of voltage we already know that Vm sine omega t, and instantaneous value of current just now we derived, that is Im sine omega t, whereas Im is given by Vm divided by R, and phi is nothing but 0 degrees just now we derived. So now we need to substitute the value of this voltage and current into the instantaneous value of power, so that I can rewrite power is given by Vm sine omega t into Im sine omega t. So again, I'm rearranging this way, rearranging these equations. That is Vm Im sine omega t into sine omega t is nothing but sine square omega t. And we already know the basics of trigonometry. The sine square omega t, we can rewrite it as, I'll write it here, sine square omega t is nothing but 1 minus cos 2 omega t divided by 2. So now I'll substitute here p equals Vm Im 1 by 2. I'm taking out it Vm Im by 2. Sine square omega t is nothing but 1 minus cos 2 omega t, cos 2 omega. So that I'll write 1 minus cos 2 omega t. So now I'm opening this bracket. You can get Vm Im divided by 2 into 1 is nothing but same, minus Vm Im divided by 2 into cos 2 omega t. So now this instantaneous value of power, which has two components. So you can observe the first component, that is nothing but Vm Im divided by 2 is nothing but it is a constant power component. Constant power component. Similarly, one more component, that is Vm Im divided by 2 into cos 2 omega t, is nothing but fluctuating power component. Fluctuating power component. So now you observe these two components. In case of fluctuating power component, so it has 2 omega t, is nothing but the fluctuating power component which is having the frequency. Actual frequency is omega t, but it is having the frequency which is double the frequency of input voltage, so that this term will be neglected, or else this will be zero, so that you can get the average power, that is nothing but capital letter P. Average power is given by only considering constant power component, that is Vm Im divided by 2. So now I'll rewrite these two as root 2 and root 2. So I can rewrite these two as a root 2 into root 2 is nothing but root 2. So that I'll write it as Vm by root 2 into Im divided by root 2. And we know that again, we know that Vm by root 2 is nothing but Vrms. So Vrms is denoted by capital letter V. Similarly, Im divided by root 2 is nothing but Irms, and this will be denoted as capital letter I, so that power in pure resistor is given by V into I in terms of watts. And this is the power derivation in AC through pure resistor. So now you need to draw the waveform for power and voltage and current. So that I will consider now with respect to omega t. So in a y-axis, it is having voltage, current, and power. Here, VIP. So now I will draw the voltage waveform. That is a pure sinusoidal waveform because the supply is the reference. So that I will get voltage waveform like this. This is voltage V, is given by Vm sine omega t. So now we already know that current which is in phase with the voltage, so that the current waveform that follows the voltage waveform, but the amplitude of current waveform is less than the amplitude of voltage waveform, so that you can get current waveform like this. This is current, whereas the current which is given by Im sine omega t, this current is given by Im sine omega t. So now 0 pi, 2 pi, 3 pi, 4 pi. So to get the power waveform, we know that now P is given by V into I. We don't know the value of voltage and current, but we can see the polarity of voltage waveform and current waveform in this waveform, so that you can observe during the period 0 to pi, during this 0 to pi. So the voltage waveform that is positive, and also the current waveform is positive. V is positive and I is positive. You know that plus into plus is nothing but plus, so that the power waveform will be comes in positive half cycle, but the amplitude of power waveform that will be more than the amplitude of voltage and current waveform. So this is power waveform. Plus into plus, you can get positive. Next, the voltage is negative, current is negative, that is in a negative waveform, so that minus into minus is nothing but positive again. You can get the power waveform again in a positive cycle, and it continues like that. Again, plus into plus plus, you can get waveform of power like this. Again, minus into minus plus, so that you can get average power. So this is your average power. That's nothing but V into I. It has only magnitude. There is no direction in power, whereas the power is a scalar quantity. So this is about AC through pure resistor. So you have to remember, in case of AC through pure resistor, by taking voltage as a reference, current is in phase with the voltage. If you're taking current as a reference, voltage is in phase with the current at an angle of 0 degree. In phase is nothing but, again you should remember, V is given by Vm sine omega t, and I is given by Im sine omega t, whereas Im is given by Vm divided by R, and the phase angle which always 0 degree, and power is given by RMS value of voltage and RMS value of current. So this is about the explanation of AC through pure resistor. So if you're having any doubts, feel free to write in the comment box. I hope you're understanding the concept. So let me come with the next concept, that is AC through pure inductance. Till now, take care. Have a nice day. If you really like the video, do subscribe and share maximum. Thank you so much. Have a nice day.